Start PPMs. That's why. You're right.
Okay, so
Oh, so it's going to sell you in Chicago.
Yeah, Ryan's telling me I'm in Chicago.
oh,
Yeah,
But y'all
it's boost your location.
hey.
Yeah, you're right.
So what we're gonna do is we're gonna talk about true north system and what other systems can go by. Bearing. So let's start talking about bearing first. So we're gonna start by what is true north system and versus the older system.
Not even point.
So let's talk about old system first. And we're gonna talk about both systems together. So we're gonna name it old system because I don't know what that system's name. So the old systems look like this. If I have north 34 degree west, north 34 degree west, it's basically always start with the first. This is what you're starting. So starting here. And this is degree away toward west. Okay? So north 34 degree toward west. Okay? So some people don't understand that. So starting with north and going 34 degree toward west, which way west is. So for example, if I have a bearing here, north, east, south, west, north 34 degree west is going to be right here. Oh, the other way, sorry. Don't know my drawing. So 34 degrees. It's not this part 34 degrees. It's this part that is away 34 degree west. Okay, so that is 34 degree north, 34 degree west. Okay, so are we okay here? Can you draw out that south 20 degree east? Make sure you place the angle is right between the north and the away here. Make sure you do that.
I'm going 20 degrees east, so it'd be
Which quadrant will it be?
fourth.
Be fourth, right? But is this drawing correctly? Is that drawing correctly?
No,
No, why is wrong with it?
they say 30 away from the sun.
It should be this way, right? So the correct way is should not be here because this one is actually going from here towards south, which is that's not correct. So then it's not this way. So you say, okay, well, what is the correct way? It's 20 degrees south, based on the south, 20 degrees east. So this is my direction I'm heading up, bearing. Are we okay here?
Yes.
Yeah.
Okay, but this is the old system. Now we're going to talk about the true north system. So true north is the one that true north system is much easier. You don't have to deal with two angles. You only have to deal with one direction, which is north. So here is the north. Okay? Then let's just say the same thing. North 34 degree west. So the true north system is based on the north is 0 degrees. Just like how you do it with a cell phone. Do you realize that north is 0 degrees? And if you face east, it goes around how many degrees? 90 degrees. And if you're facing south, what you get? 180. So it's clockwise. Do you see that it's going this way? So it's clockwise, just like how your clock work. True north is based on the clock. It's just this way, 12 o'clock is always facing north. You know, do you ever sing like, movies? Nobody uses this anymore. You know, you see a beautiful girl at 9 o'clock, right? Check out 9 o'clock, your 9 o'clock. right? It's a beautiful girl at 9 o'clock direction. You're like, which part is 9 o'clock? But 9 o'clock is what? Jaden's beautiful, obviously. Yeah. So for relative, for Daniel, you will say, oh yeah, 1 o'clock. Check out my 1 o'clock, it's pretty girl.
Oh, I knew.
Okay, so then, or it's related on a person, right? The person's what the clock's direction for them. So that you can tell them without saying, oh yeah, look at the one on the right. It would be too obvious. You know, your 9 o'clock will be much better than anything else. So that's the way that to go by. So how do I represent the same north 34 degrees? So north 34 degree west. How do I represent in a true north system?
356, north 356.
Almost, but you have the right idea, but it's almost there. It's not that.
It's not 350.
324.
326.
326.
326 or 326. So it'd be 326 degree north. So this is a way to talk about conversion between this is the old system to the new system. Because it's toward this side, so therefore it's this way, it's 326 degrees. Does that make sense?
Mm-hmm.
So I'm going to give you a couple systems and ask you convert to each other. So let's say if I have south 33 degree east, I want you to convert to true north. So what will that be? True north on this side. And this is the old system. So older system. And the new system. So if I have true north at 171 degrees, what is the old system as?
Okay.
South 33 degree east. What would be the true north system is? And if I have true north is 171 degree, what is the old system as?
Huh? No, like they gave you the true north 121 and make it into like south.
Yeah.
something else.
So let me point out this way. North 171 degrees. You guys don't say that anymore, right? Check out your 9 o'clock.
Yeah, look over there.
I mean, I see it. I see it.
Look over there, don't care. I'm like, that one. Kind of like me, look, I'm like, who, that one?
You guys are so obvious. Like this generation is very blunt,
I'm subtle.
very direct.
I'll do that if I know the person. If I don't know you, I'm not gonna point at you.
Hey, look.
Mama, look. I used to understand.
The ugly girl over there.
Is that a 170?
Yeah.
Oh, it's supposed to be
I'm saying
Somebody eating too much bean?
I have the
Well,
other one.
it's really bad over here. I was smelling it, but I don't want to say anything.
Yeah, Andrew. Yeah.
Yeah, you should say, who did this?
Is there something?
So this is the true north, right? What will be the whole system like?
No,
This
east,
will be true north like.
Yeah, well, what do we south 9 degrees?
south 9 east.
East, yeah.
South 9 east, yeah.
What is it?
On the
The
bottom one.
bottom one.
But the other one?
Yeah, south 9 east. South 9
South,
Yeah, 9 degrees.
Yeah, south
9 degree,
And it's east.
east. Does that make sense?
Yeah.
How about the top one?
147.
We're trying to connect
North.
together.
What?
147.
Is north 30 degree east, south 30 degree east, so it's this way, so 33. So it'll be 180 subtract 33, so it's what?
147.
147 north, right? So that's how you convert from one direction to the other direction. Now, we're gonna talk about a shift that is is going to a harbor, for example. So we're going to talk about bearing. We're going to talk about bearing a lot. Why are we going to talk about bearing? Because later we can find if a ship's going this way, a ship going this way, and for how long, and you want to see a distance between that, you have to use law of cosine. You might have to use law of sine. You might have to talk about a vector. So for example, if I'm going north and there is a southeast wind at 40 miles per hour, then how does that affect the airplane? Okay, we can deal with vectors, so we can deal with bearing 3 different times, but this is the first time I'm introducing to you. The second time will be deal with law of sine and law of cosine. The third time will be vectors, okay? Because the vector is gonna have wind component and the airplane's direction components. So now we're gonna talk about this. So we're gonna start with a question. The question is posed on a model. So can you turn on the model and look at the questions? And your notes based on that. The first question. You're gonna try to do the second question. But the problem is drawing. The problem is drawing. If you can draw the problem, you'll be good. If you cannot draw the problem, that's where the problem is.
I already drew.
So let's draw a harbor.
Things change for you.
Okay? A harbor is right here. And we're gonna name it harbor. A harbor is going this way. So everybody look at here. You can look at a picture too. So the first question says harbor, and the ship is going a direction. Can you tell me what a direction is?
North 42 east.
So which quadrant will that be?
That would be first.
First quadrant, right? And it's also a true north system. So because 42 degrees is exactly true north. So we're gonna draw axis here. That's the north. So we're gonna go 42 degrees. So we're gonna say that's 42 degrees. Are we okay here? And going for how long?
25 miles.
25 miles. So we're gonna say this is 25 miles. Is that too hard?
Not yet.
Okay, so the ship's gonna stop. The ship's decided to turn off the engine and stop at exactly 25 miles. And it's gonna turn 90 degrees. Okay? So without reading the second part, the 90 degree is really the key part. So do I turn right or left?
Right.
I turn right because clockwise, right? So this is my 12 o'clock and I'm turning at 3 o'clock, whatever. So I'm gonna go this way. Okay, so this is about 25. So I mean, they probably draw a little bit longer for 18. So this is it's gonna turn 90 degrees. Now, without telling you that, actually I can figure out what is the direction I'm facing. This is what the core is. If you understand geometry, you take the geometry, what, a year ago or last year?
2 years ago. 3 years ago.
Yeah,
2 years ago, you learned something like this. This is it's on tomorrow's SAT, that's what I'm reviewing for you, is if you have 2 parallel lines, and how do I identify that parallel line is we draw this arrow. Do you remember this? That means 2 lines have same slope. That's also another concept on SAT, is if you have no solution, then those 2 lines have the same slope and different y-intercept. Now if I draw a transverse line, this is called transverse line.
Oh yeah, I remember this.
Transverse line. Now, I hear this called interior. So for here it's called interior. I hear it's called exterior. I hear it's called exterior. Do you guys remember this?
Yeah, I remember that.
I remember that exact picture.
So now this one, we're gonna call this angle 1
Oh, yeah.
and angle 2. Angle 1 is congruent to angle 2 because it's called alternative interior angle.
I remember those.
Alternative interior angle. So sometimes they'll give you some like 2x plus 1, and this one is like maybe 5x plus 20, something like that. And you want to set those two equal to each other, solve for x, and find out what this angle is. Remember this?
Yes.
Sort of.
Those two angles are congruent. It's gonna be on tomorrow's SAT, I promise you, it's on there. And you're gonna be laughing at it now because tomorrow you're gonna see exactly the same thing. You're gonna set those two angles equal to each other because there's an alternative interior angle. Another way to ask is this. This angle. This angle 3. Angle 3 and angle 2, what's the relationships?
They equal one.
Oh, maybe what do you get it?
Angle, okay, so angle 1 plus angle 2 is equal to angle 2 because alternative interior angle. But angle 2 plus angle 3 is supplementary.
Supplementary.
So it's 180. So how do I know it's supplementary or complementary? Here's how do you tell. Supplementary angle pair is equal to 180. How do I know that? A complementary angle, you're gonna see this term, complementary angle, is equal to 90. How do I know complementary is 90 and supplementary is 180? Here's a trick I'm gonna show you. You don't need to memorize, just draw a line. Use this, draw a line on the first letter. Boom. What do you see? What number do you see?
Over.
8.
Oh,
So it's 1/8. You draw a line on the complement. What do you see? 90. So it's 90. Complementary is 90. Supplementary is 180. Angle 3 and angle 2 are supplementary.
Oh, I thought it was 1 and 3 or supplementary.
1 and 3 is also supplementary.
Oh, they are.
yeah.
That's why angle 1 is equal to angle 2. Because angle 1 plus angle 3 is 180. Angle 2 plus angle 3 is 180. Therefore, angle 1 is equal to angle 2.
Angle 1 and 2.
Also, they're going to ask you tomorrow something called vertical angle. 4. Angle 1 is equal to angle 4. That's called vertical angle.
What does that mean that 4 is equal to 2?
Yes. 4 is equal to 2 is called corresponding. Angle 4 and angle 2 are corresponding angles. Is that kind of review a little bit?
Yeah.
Okay, so angle 4 is equal to angle 2. Angle 1 is equal to angle 4 is because vertical. Angle 1 and angle 3 are supplementary or straight angles. Angle 3 and angle 2 is also supplementary. So those are the things that you need for tomorrow's SAT. Most of you guys look at me, I'm crazy, but I'm not.
You're not crazy, Mr.
Thank you, I appreciate that.
Yeah, let me see.
So now we're gonna look at this. I'm gonna draw a new axis here. I'm gonna use red. I'm gonna draw a new axis. And I'm gonna draw an axis here. And of course, this line are parallel to this one. Because north doesn't matter where you stand. Here's north, and here's also north. Therefore, this is a 42 degree. Which angle is 42 degree as well?
That one.
This one right here. So 42 degrees, right? So that makes this one as what?
That makes it
48 degree.
yes.
Because they are complementary. Thank you. Although nobody answered that, I answered that myself.
I got you.
So therefore, do you see the question? The question says, the face in the near direction is what? South, 48 degree east.
Yes.
So I don't even need that information to know that they are facing south, 48 degree east.
Okay.
Yeah,
I get it. I get it.
Okay, so now not only that, the question is asking you, just for example, if I have a harbor, right?
Yes.
If I drive here and I turn 90 degree and go in for 18 miles, so this is 18 miles right here. Now, my ship broke down. Okay, it broke down. It has a hole and started leaking. Okay, so I have an issue. Now I'm gonna send a rescue ship to here. How far I had to go? So, good job, Jaden.
Oh, you heard me?
Yeah, I hear you. What is it?
A squared plus b squared equals c squared.
Good job, because this is gonna form a right triangle. Do you see this right triangle? And we're gonna call this side C. And so we're gonna redraw that. Okay? We're gonna redraw that. We're gonna say this one is the 90 degree, this one's the 25, this is the 18. So I can find out the C, so it'll be 18 squared plus 25 squared equal to C squared. C is equal to square root 18 plus 25 squared. And that's equal to, I believe, 30.8, I don't know. 33.8 or 30.8. Did you get it?
Just a little bit.
So then I know I have to go with 30.8 miles. Is that true?
Yeah.
Take forever.
Equals 661.
Huh?
Oh, let's square root it. 661. Square root. I found it. Yeah.
Any day now.
25.7.
No, I think you're wrong.
I got it.
All that work to get it wrong. Good stuff.
Yeah, it's 30.8.
Sounds like me.
It's 9:49.
Yes, 30.81.
Yeah. Now here's my second question. What's the second question asking? Can you read the second question? Second part?
The bearing, the nearest,
Find the bearing. What?
So nearest 10th degree of the boat from the harbor entrance.
Okay, so what if I want to send a ship? I know I have to go 30.8 miles, right? But if I want to send a rescue ship to here, which direction I'm facing? I have all those possibility, right? I need to find out what's my bearing and have the steering towards. So therefore, I need to figure out what?
42 plus 90.
42 plus 90, then that's going to be here and this. Let's add together. No. I'm steering from harbor. I'm going to send a rescue ship. So therefore, which line I'm going to drive? I'm going to drive this line or this line?
No.
The second one, right?
So like north.
So therefore, it's a right triangle. That this is the angle that I'm looking at. This is the data, and this is the data. But that's not a final bearing. The final bearing is this. The final bearing is equal to the 42 plus the data. Does that make sense? But how do I figure out this data? You do your thing, right? 10 data is equal to what? 25, no, 18 over 25. Pay attention. This is how you get an angle. I need to get rid of 10. I cannot divide it by 10. I need to do 10 inverse on both sides. And that's how you use inverse. So data is equal to 10 inverse of 18 over 25. And that's equal to what? I think you get 35.8 degree.
yeah.
But that's not a final bearing. Remember, we're going from here to here.
42 plus 35.
So it'll be left with 77 degree, 0.8, I think. That is north, 77.8 degrees, or north, 77.8 degree east. They both have final answers. So now, before the class, now in the class end, you're gonna try the next question. You're gonna draw it. You're gonna draw it. Now, how many question bearing on the final exam? 3. This is the first one.
Where's the final exam?
Final exam is happens somewhere in May.
Oh,
Okay, the final exam might able to rescue some of your grade because that counts like 20 or 30% of your final grade. So if you did well, and that one is also curved.
Yes.
And like all my other tests is not curved, but that test is curved. If you did better than other class, guess what? I have 1 year, I have 80% of students got A. But that was 1 year. where my average is 20% higher than other classes. But ever since that, I don't think I ever did that well. I think most of my year I did 10% better than other people. So,
Damn.
but I'm still doing better.
That's the,
But also my classes are harder
I appreciate that.
because I will spend time to go through bearing. Other people will not spend time because that's too hard for students to understand. But I'm gonna still teach you because I think this is probably the only thing that's relevant in real life. A lot of things is not relevant, but bearing, you do need to have to understand direction in order how the world works. Otherwise, you're gonna think like Earth is flat.
saying it isn't flat?
Let's see as I be looking your
There are a lot of people believe Earth is flat.
That's crazy. I thought it
Have
was
you
joking.
seen the whole YouTube channel
Yes,
about
I've
them?
seen
What, flat?
Their whole theory is
Flat Earth theorem?
Yeah.
They have all kind of theorem that says flat Earth is flat.
it. Why doesn't the ball move and you put on the food there?
So is it just a 42 always, or is it,
That's according to the question. You have to look at the original question.
Okay, what are you doing?
So you're gonna do the next question. You're gonna draw the picture. You're gonna draw the axis.
ooh, entrance of the hiking trail.
Here is gonna be so confusing.
There's 2 questions posted. I just went over the first one. You're gonna do the second one.
I don't
I'm asking
understand
how you
bearing.
can find the bearing. How do you get 42?
I didn't get 42.
It's just a stat. It's
This is a 42. That's the one I was driving originally, right? Once you got this right triangle, you find this angle. Then this angle plus 42 is the final bearing from here to here. If I send a ship going toward this way, I have to go 42 plus whatever this angle is.
Okay.
And that angle I'm using arc10 to get it because that's right triangle. Now all the time it's right triangle, but this is the case we start practicing. We're practicing with right triangle. Because later, they don't have to turn at 90 degrees. Later, they can turn at 78 degrees. Then you have to using something like log sine, and you have to using other things, log cosine to find the distance. Or vectors, you have to deal with vectors later with the wind. So if I'm driving the airplane this way, right? And the wind is blowing this way, guess what? It's gonna bend the airplane going in a different direction. So if you fly to New York, the wind's blowing this way, then it's gonna push this way. So the airplane need to drive toward a little bit here, so wind blow, it's gonna bend toward New York. So those are the things the pilot had to think. So those are the only thing that's practical in life. I already told you, none of the thing we learn is practical in life. But understand vectors. So Brendan is also asked me the same thing. He says, oh yeah, I understand the linear velocity, angular velocity, because that's practical in life. But this is what's practical in life. Now, to understand all other things may not be practical, like for example, polar coordinates. Might not be practical in life, because you're probably more likely you're not gonna use it. But bearing, if you become a pilot, they make it what, 120,000 a year, or $100,000 a year? That's good money. For understand bearing, to understand how airplane works, and those are practical knowledge. So pilot is actually a good thing to do if you guys are interested in flying.
Okay, Mister, what's the answer? It's like got something?
I'm actually
Pursue
confused.
the answer, yeah. Okay.
I'm confused.
You guys go
I got both the answers.
17.54.
Huh?
Like, well,
What'd you get?
I need to calculate.
No, just say like the square root of what?
17.54.
Yeah, that's what I got.
Okay.
Now,
And the second part?
I did work out.
I'm confused.
I need to look at the question.
So, ready? So, it's like, and
Did you draw it? Yeah, draw it. Try to draw. Now, Andrew's gonna come help you draw the diagram if you need help on drawing diagram.
yeah, I need help. Can you help me draw? Yeah.
What's that number?
So, what is it? So I got the
Keep saying it, that's why I asked. That's why
Three.
that's why I helped you.
2.3 miles down.
You're gonna draw it, you're gonna drawing, right? So you're gonna draw it here.
West, okay. So, No, in your line, I think
So you go down 2.3.
yeah.
Okay, so,
And then it says turn 90 clockwise.
so what a question, draw, you're gonna draw it for me. Let's draw axis, let's draw what, so entrance of system hiking, right, so it's gonna be here.
This is the right
I'm
spot.
gonna draw a box. So, we go in which one?
Because
Draw in the middle.
angle from here to
He
Don't you guys married?
you can
did it on the
Leaving the harbor, but this is west, right? It's hiking south, 31 degree west. So this is the north, right? So 31 degree west, what it is. Yeah, here, 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 here. No, I did not. South, 31 degree west. This 31 degrees. Here, 31 degrees. And then turn 90-degree clockwise, so you go this way, turn 90 degrees, so 90 degrees.
But right now. But then it says.
And north, 59 degree west. Yeah. This is 59.
I think it's from here to
That makes sense? 2.3, and this one had to go a little bit further than 2.3. So, that makes sense? So this is a 59 here, so I can figure out 2.3, this is a 90 degrees. So this is the right triangle here, and 3.5 and 2.3. You can figure out square root of 3.5 squared plus 3.3 squared. I don't know what that is.
oh, because you do the line, then you do the line, you do that wait for.
Oh, wait, Bentley, my pencil.
Huh?
That's the second.
Yeah, but it just says you go, and then it says you go, not north to 9 degrees west, by about miles, right? So then the line, the first line you drew, or you drew your axis, right, your second axis, and you see it's like right there, which is what you drew.
Mr. Yang, is that,
4.15, right? So this is 4.15, right? Yes?
is that for that one to nine?
I mean, you can,
No.
you can go a little better.
So 417. So now, all we gotta do is figure out this angle right here. Can I figure out this angle? Using arc10. So arc10 of 3.5 over 2.3. So once you figure out that angle, so arc10
This is
of 3.5
here,
divided by 2.3.
and then you can get full triangle.
So it's gonna be 56 degrees.
See, like, right.
But that's not the final bearing. You have to add it. So 31 plus 56.68. So it's equal to 87.68. So going from here to here is 87.68.
You want to stop this?